Hello everyone, how are you all? My name is Paparao. In the previous video, we have discussed one problem in exercise 12.2 surface areas and volumes lesson, right? So recently we have started surface areas and volumes lesson, and we discussed about one problem in exercise 12.2. Now we will see the second problem in exercise 12.2, right? Right. So one second. Actually, the second problem is Rachel, an engineering student. Actually, I will read the given problem and I will draw the diagram which is suitable to this question, and later I will explain the meaning and solution. Rachel, an engineering student, was asked to make a model shaped like a cylinder with two cones attached at its two ends by using a thin aluminium sheet. So here, observe the given figure. Observe what figure is given in the problem. Here one cylinder is given. This is the cylinder. One cylinder is given. So here she made one cylinder with two cones attached at its two ends by using a thin aluminium sheet. So very simple, and here one combination of solid figure is given. In first video I explained what is combination of solid figure. Combination of solid figure means a figure which is formed by more than one 3D figures is called combination of solid figure. Observe the given figure here. So this figure is formed by one cylinder is given here, one cylinder, and two cones are attached to both ends of the cylinder. This is first end of the cylinder. So at one end one cone is attached, at another end another cone was attached. So here two cones are attached to the two ends of the cylinder. So what do we say about the given diagram? In the given diagram, one cylinder is given. The cylinder has two ends. At two ends, two cones were attached. So this is the diagram. The given diagram shape is combination of solid figure. If a figure is formed by more than one three-dimensional figures, that is called combination of solid figure. Here, is it formed by more than one figure or not? This figure is formed by more than one figures. First one is cylinder. One cylinder is there, and two cones are there. These two cones were attached to ends of the cylinder. Okay. Now we will see the measurements. The diameter of the model is 3 centimeters. What is 3 centimeters here? The diameter of the given figure. Diameter. So the diameter of the model is 3 centimeters. So remember one thing. This figure diameter is 3 centimeters. This figure has three figures actually. This figure is formed by three figures. First one is cone, second one is cylinder, third one is hemisphere. Right? So diameter is common to three figures. So 3 centimeters is belongs to cone, 3 centimeters is belongs to cylinder, 3 centimeters is belongs to cone. Very simple, and here one solid figure, one figure is given, and that figure is formed by two cones and one cylinder, right? So these three figures have one common diameter. Their common diameter is 3 centimeters. So diameter is 3 centimeters. Then what about radius? Radius is half of the diameter. So radius is equal to 3 by 2. What is 3 by 2, Andy? 3 by 2. What is 3 by 2 here? 3 by 2 is the radius of cone. 3 by 2 is radius of cone, radius of cylinder, and radius of cone. So three figures have same radii. Very good. And The diameter of the model is 3 centimeters and its length is 12 centimeters. Length, the total length of the 3D figure is 12 centimeters. Remember one thing, here 12 centimeters is the length of the 12 centimeters is the length of the given three-dimensional figure. But if you think 12 centimeters is the length of the cylinder, that will be wrong. 12 centimeters is not a length of the cylinder. 12 centimeters is the total length of the 3D figure. Right, Amma? Did you understand my point? What is 12 centimeters? Is it the length of cylinder or total length of the 3D figure? Yes, it is the total length of the figure. Right, Amma? And next one. If each cone has a height of 2 centimeters. Very good. Cone height is specifically given here. What is height of the cone? Height of the cone was clearly mentioned 2 centimeters. And second cone height was also 2 centimeters. Find the volume of air, okay, contained in the model that Rachel made. Very simple problem, and first you have to understand the meaning of the given problem. Here, Rachel made one three-dimensional figure. She made this three-dimensional figure with the help of two cones. These two cones are attached to ends of the cylinder. So, Rachel made one three-dimensional figure which is formed by one cylinder and two cones. Right? These two cones are attached to ends of the cylinder. But now next we want measurements. Already cone, three figures have same diameter. Actually this is mentioned in the problem. The three figures have same diameter. So cone diameter 3 centimeters, cylinder diameter 3 centimeters, and cone diameter also 3 centimeters. So diameter is 3 centimeters. So then radius is 3 by 2. So radius is 3 by 2. Next, cone height was given. Cone height was 2 centimeters and this cone height was 2 centimeters. But what about cylinder? Cylinder height was not given. First we have to find the height of the cylinder. If you want to area of the given solid or volume of the given solid, first we have to find their measurements. First we have to know their measurements. If we know their measurements, then we will find their area or volume. If we don't know about their measurements, then we can't find anything. So first we have to check the measurements of the given figure. Cone complete measurements are given. Cone radius is given. Cone radius is 3 by 2. Cone height is 3 by 2. Sorry, cone radius is 3 by 2. Cone height is 2 centimeters. This cone measurements also given. This cone radius is 3 by 2. This cone height is 2 centimeters. But cylinder, what about cylinder? Cylinder radius was given. Cylinder radius means half of the diameter. Cylinder radius was 3 by 2 centimeters. But what about cylinder height? Cylinder height was not given. But if you observe carefully, we can easily find the height of the cylinder. Already the total length of the three-dimensional figure was given. What was the total length of the three-dimensional figure? 12 centimeters. But we want only the length of the cylinder. So this is the length of the cylinder, some x. Very simple, and this length was 2 centimeters. Cone height 2 centimeters. This cone height 2 centimeters. 2 plus 2, 4. If we subtract this 4 from 12, then we will get height of the cylinder. Very simple. Did you understand my point? The total length of the 3D figure is 12 centimeters. Right? Actually, cone is a part of three-dimensional figure. This cone is part of three-dimensional figure. Cylinder is also part of this three-dimensional figure. Cone height was given. First cone height 2 centimeters, second cone height 2 centimeters. So 2 plus 2, 4. So these two cones have taken 4 centimeters. So the remaining length belongs to cylinder. So first you add 2 plus 2, 4. And subtract 4 from 12. 12 minus 4, 8. So what is height of the cylinder? Remember one thing, height of the cylinder was not given. To find height of the cylinder, we have to add this cone height, 2 plus 2, 4. And remove 4 from total length 12. 12 minus 4, 8. So it is the, very simple, 8 is the height of the cylinder. So we want the total volume. So what is the question? The The question is we have to find the capacity. Capacity or volume, both terms are same. So we have to find the volume of this object. To find the volume of this object, volume of the given object, very simple, and we can easily find out the volume of the given object, and first we have to find volume of cone, and next we have to find volume of cylinder, next we have to find volume of cone. If we add these three figures volume, then we will get the answer. So volume of two cones plus volume of cylinder will give us volume of solid. Did you understand? Volume of two cones, these two figures are same. So volume of two cones plus volume of cylinder. Okay, volume of first cone, otherwise volume of first cone plus volume of second cone plus volume of cylinder. If you feel it is difficult, you can find their volume separately. Volume of first cone plus volume of second cone plus volume of cylinder. It will give you volume of given 3D figure. What is volume of cone formula? Very simple. 1 by 3 pi r square h. Plus volume of second cone formula also 1 by 3 pi r square h. What is volume of cylinder formula? Pi r square h. First I wrote three formulas. Amma, very simple amma. Volume of first cone plus volume of second cone plus volume of cylinder will give you the answer. Okay, there are three terms in the given expression. 1 by 3 pi r square h is first term, 1 by 3 pi r square h is second term, 1 pi r square h is third one. So now I have one idea. Now I want to take out the common terms in given expression. I will find some common terms. Can we find any common terms here? First I will expand it. 1 by 3 into pi value 22 by 7. R square. R means what? R means what? Radius. Whose radius it is? It is the radius of cone. What is our radius of cone? Radius of cone is 3 by 2. 3 by 2 square, whole square, into height. What was the height of the cone? Height of the cone was given 2. Amma, this is the volume of cone. Plus, next, volume of second cone. Second cone measurements also same. 1 by 3 into pi value 22 by 7 into r. R means radius. What is radius of the cone? Radius of the cone is 3 by 2. But r square 3 by 2 whole square into height. What is height of the cone? Height of the cone is 2. This is the volume of second figure. Plus volume of third figure. Volume of third figure is cylinder. What is volume of cylinder formula? Pi r square h. Pi value 22 by 7. R means radius. What is radius of the cylinder? Radius of the cylinder and the radius of cone are same. 3 by 2 whole square into height. What was the height of the cylinder? Height of the cylinder was 8. How did we get this 8? Very simple. Already total length of the figure is given. Total length of the figure is 12. Here cone height is given 2. Second cone height is 2. So I added 2 plus 2, 4, and I subtracted 4 from 12. 12 minus 4, 8. So 8 was height. So this is the volume of the third figure. Next I will expand the terms. 1 by 3 into 22 by 7 into 3 by 2 whole square means 3 by 2 repeats 2 times. 3 by 2 into 3 by 2 into 2. Keep it in brackets. Plus next 1 by 3 into 22 by 7 into 3 by 2 whole square. Expand it. 3 by 2 whole square means 3 by 2 repeats 2 times into 2. Next third one, plus 22 by 7, 22 by 7 into 3 by 2 whole square, 3 by 2 into 3 by 2 into 8. Now let us identify the terms which are common. Shall we find any common terms in 3 volumes? 22 by 7 is common, not cancel. 22 by 7 is just common. 3 by 2, 3 by 2, 3 by 2 common. 3 by 2, 3 by 2 common. Okay. Okay. So these are the common terms. Okay. Now take out the common terms here. 22 by 7 into 3 by 2 into 3 by 2 are common. Now write the remaining terms in first group. This is first group, second group, third group. Which one is left? 1 by 3 into 2. 1 by 3 into 2 plus now second group. Coming to the second group. Which one is left? 1 by 3 into 2. Oh, sorry. 1 by 3 into 3 by 2. Okay, already 2 3 by 2s are common. Only 1 by 3 into 2 common. Next, coming to the third group. Which one is left? 22 by 7 common. Only 8 is left. According to BOD-MAS rule, first we solve bracket values. So 22 by 7 into 3 by 2 into 3 by 2 into 1 by 3 into 2. First I will do multiplication. We know very well about BOD-MAS rule. First we have to give first preference to brackets. Bracket values are there. Next we have to solve off. No off is there. Next division. There was no division. Next multiplication. Yes, multiplication is there. 1 by 3 into 2. Right, 1 here. 1 2s are 2. By 3 1s are 3. Plus next. Multiply 1 by 3 and 2. Right, 1 in denominator. 1 2s are 2. By 3 1s are 3. Plus 8. Okay, ma? Next to do addition. Now we have to add 2 by 3, 2 by 3 and 8. Okay, first I will add 2 by 3 and 2 by 3 because the denominators are same. 22 by 7 into 3 by 2 into 3 by 2 into denominators are same. So write the denominator is 3. Add 2 and 2. 2 plus 2 4 plus 8. Next add 4 by 3 and 8. Let's do cross multiplication. Cross LCM. 22 by 7 into 3 by 2 into 3 by 2 into. Very simple, amma. First write by. First multiply denominators. 3 1s are 3. Next to do cross multiplication. 1 4s are 4 plus 3 8s are 24. Here I have done cross multiplication. First multiply denominators. 3 1s are 3. Write 3 in denominator. Next do cross multiplication. 1 4s are 4. What is the symbol here? Plus. 3 8s are 24. Now add 24 and 3. 22 by 7 into 3 by 2 into 3 by 2 into 4 plus 24, 28. 28 by 3. Now cancel them. 7 1s are 7. 7 4s are 28. Right? 3 cancel. 2 1s are 2. 2 2s are 4. Again 2 1s are 2. 2 1s are 2. Which one is left? 22. I will write here 22 by 1 into 1 by 1 into 1 by 1 into sorry, once again I will do cancellation. 22 by 7 into 3 by 2 into 3 by 2 into 4 plus 24, 28. 28 by 3. Okay. 3 cancel. 3 1s are 3 1s are. 7 ones are 7 fours are cancelled. Next, how 7 ones are 7 fours are, 3 ones are 3 ones are. Next, 2 ones are 2 twos are, 2 ones are 2 ones are. Which one is left here? Did we cancel all? 22 by 1 is left. 22 by 1 into 1 by 1 is left. 1 by 1 into 3 by 1 is left. 3 by 1 into 1 by 1. Multiply them. 22 ones are 22. 22 threes are 66. 66 ones are 66 by 1 ones are 1. 1 ones are 1. 1 ones are 1. So 66. So what are the units of volume? Units cube. So here measurements are given in centimeters. So 66 centimeter cube. What is 66 centimeter cube? 66 centimeter cube is the volume of the given figure. Very simple indeed. Here one figure is given. Rachel made one figure. This figure is formed by one cylinder and two cones which are attached both ends of the cylinder. Very simple indeed. Here one cylinder was given. The cylinder has two ends. At the two ends, we placed two cones. So their measurements are given. The cylinder cone diameter is 3. The cone height is given 2 centimeters. This cone height is given 2 centimeters, and total object length is given 12 centimeters. The question is, and he asked us to find the volume of the given figure. Very simple. How did we find the volume of the given solid? First we found the volume of first cone plus volume of second cone plus volume of cylinder. I wrote formulas 1 by 3 pi r square h plus 1 by 3 pi r square h plus volume of cylinder pi r square h. I substituted values and I have taken common terms in 3 groups and I solved bracket values and finally I got the answer. Very simple. The Rachel made one figure which is formed by combination of solid figures. So this is a combination of solid figure. This figure is formed by one cylinder and two cones. These two cones are attached to the cylinder at their ends. I hope you understood this problem very well. Thank you very much. Have a nice day.